Hello everyone. In this video, I will show you how we can solve problem 4 of workshop 2. In problem 4, we are given a spreadsheet where we have the historical monthly returns of two funds from July 1963 to December 2014. And we are given a risk-free rate of 0.3%, and we have a number of requirements. First one is we need to identify which one is a good measure of returns, the arithmetic mean or geometric mean, and we need to calculate both of them. Since geometric mean considers the effect of compounding, so it's a good measure compared to arithmetic mean. Now let's see how we can calculate the returns for these two funds. So here are the two funds. Here's the information we are given, fund 1 and fund 2. So first of all, let's copy these two names here. So first of all, we will calculate geometric mean. And to calculate geometric mean, we need to add 1 to each of these returns, because that's the formula for geometric mean. 1 plus return multiplied by 1 plus return multiplied by 1 plus return of next period, this way. So let's equal 1 plus this one and equal 1 plus fund 2's return. So these are the return of fund 1 and fund 2 after adding 1. So we just scroll it down and we change the raw returns to 1 plus return. Now we can use these inputs to calculate geometric mean. So equal geometric mean is this one. We just select the whole column by clicking Shift Control down arrow simultaneously. We finish the bracket, and since we added 1, we deduct 1 here. So we get a geometric mean. Let's change it to 2-digit. Okay, so percentage. So it's 0.57%. Now if we do the same for fund 2, we just scroll it to the right and it's 1%. So that's requirement A. And let's calculate arithmetic mean now. So to calculate arithmetic mean, we will go back to our actual return given. So arithmetic mean is simply average. We select this whole column. This is arithmetic mean 0.78%. And once again, if we just scroll it right, we get 1.10%. So these are the historical returns of fund 1 and fund 2, both geometric mean and arithmetic mean. Now requirement B is we need to calculate Sharpe ratio, and we need to discuss that which fund is performing better. You know, to calculate Sharpe ratio from the problem 3, we know to calculate Sharpe ratio, we need expected return and standard deviation. So let's calculate standard deviation first. So a standard deviation, you get a lot of options. So select STDEV, that's the standard deviation, and we select this one. So this is the standard deviation for fund A, and this is the standard deviation for fund B. Now to calculate Sharpe ratio, if we take geometric mean to calculate Sharpe ratio, then we will take equal this one minus, you can remember risk-free rate is 0.3%, so we put it 0.003 divided by the standard deviation. So Sharpe ratio is 0.04. Now, if you want to calculate Sharpe ratio using arithmetic mean, you also can simply do that. Now, if we scroll it, we get the Sharpe ratio is 0.156 for Fund B. Now, we already know that Sharpe ratio measures the excess return per unit of risk. Since Fund 2 is generating higher excess return for per unit of risk, Fund 2 is performing better than Fund 1. Requirement C is identify two limitations of the use of a Sharpe ratio. Actually, the limitations of Sharpe ratio are the same as the limitation of standard deviation. There are two limitations of Sharpe ratio. One is it is not a good measure when the return is not normally distributed. So when returns are normally distributed, then Sharpe ratio is good measure, but not for a non-normal distribution. Then the second point is Sharpe ratio, as it is based on standard deviation, that provides equal treatment to upside potential and downside risk. But as we know that investors are more focused on downside risk than the upside potential. Requirement D is calculate skewness for two funds. So it's simple. We use skew function, S-K-E-W skew, and we select this return and we finish the bracket. So we get skewness, and if we just scroll it to the right, and we get skewness of Fund A is also higher and it's negative. And you understand, as we discussed in the lecture, that negative skewness indicates that there is a higher chance of getting negative return than a corresponding probability of getting a positive return. So investors will be less likely to invest in Fund 1 due to a higher negative skewness. So this is how we solve problem 4 of workshop 2. Thank you very much. I will bring new videos for other Excel activities in future. Thank you.